I'm a technical advisor for Harrison Malayalam Limited. The plant is based at Cochin, the southern part of India, and we are the largest rubber and latex manufacturers in India. I'm going to present a paper on the role of elastomeric foams for thermal insulation. You find lot many products which are used for thermal insulation. Thermal insulation is the basic need or the basic requirement in today's world. We find all the super malls or the multiplexes and the big corporate buildings and all with complete centralized air conditioning, and for maintaining the temperature inside and lowering the cost. Insulation plays a very important role. Let us go to this presentation now. As we all know, elastomers are nothing but rubbers. They have got good elasticity as compared to plastics. The difference of insulation by using foams or elastomers is they do not need any jacketing outside like the older days when glass wool used to be used for insulation, and it had to be cladded with aluminum sheets to protect from the injuries or the irritation of glass wool. I'm going to discuss about various kinds of foams which can be used for application temperatures between minus 130 degrees centigrade to plus say about 100 degrees centigrade. It could be used for cold pipelines, it could be used for cold water flowing, or it can be even used for hot fluid flowing. In comparison with foam, the earlier days what the rock wool or the glass fiber used to be very rigid, whereas the foams are very elastic and they are very soft and very easy to handle. We generally call it by two names. One is a foam, or it is also called as a sponge. Generally, sponge represents two foam products made out of elastomers, whereas foam is related to materials like say plastics or semi-plastics. Sponge is nothing but expanded rubber-based material. The foaming is done in rubber compounds with help of certain chemicals. We'll be able to see that later. We all know rubber is elastic, and there are various kinds of rubbers which can be used, like natural rubber or many kinds of synthetic rubber. Few of them to mention is nitrile foam, SBR foam, neoprene, EPDM. There has been a lot of research and development to meet the expectations or the requirements, and many synthetic rubber foams are also now available with different degree of reinforcement if required. These are the most commonly used rubbers for making foam or sponge. There are certain questions which are frequently asked. How and why the insulation is used? So you can just go through. The insulation is used to reduce the unwanted noise. It is reduced to control the noise. It is used to improve upon the working conditions, and these all standards they meet OHA or EPA. The benefits of insulation. Do we all know the benefits? These are the benefits. I think later on this PowerPoint will be shared with you. So instead of going into point by point, I would like to go through the remaining slides because in 30 minutes I have to cover nearly about 70-75 slides. The process control improves by insulation to a very great extent. The efficiency could be as much as 95%. The insulation, it helps in maintaining the process temperature. Something flowing which is very cold will remain at that temperature. If something is very hot, it will be also maintained at the elevated temperature. It improves the quality of the product, and it also helps a lot as far as safety is concerned. With insulation, we can reduce the energy consumption. That is, less fuel or less electricity could be consumed as compared to if it is not insulated. Insulation is not directly connected to pollution control, but in a way, if we go through the advantages, it certainly helps to control the pollution control. These are the ways how it can be. It helps personal protection, like accidental burns or some other accidents, because the hot surface or the very cold surface is protected with help of insulation material on top. It also helps as far as the fire protection. It gives a better improved appearance. The noise control, the noise is very much under control. A noise can be certainly a very serious impact on the workers' health or the people who are there on the shop floor, and these are the reasons why it is. These are the other advantages, like very flexible, it's non-fibrous, non-porous as far as the skins are, the foam skins are covered. It is available in sheet form as well as in tabular form, and it can be fabricated to the surface on which it has to be applied very easily. There are two types of insulations, like EMI or thermal management. Thermal is generally related to the heat or cold. EMI is related to the emissions of electronic components. This is an example of foam laminated with aluminum foil for a better temperature control, reflection of heat. Generally, these kinds of insulations are used under the roof to control the temperature inside, especially in countries like Gulf, where the outside temperature shoots up to 48 to 50 degrees sometimes. So to maintain low temperature inside, this insulation helps a lot. EMI shading, it finds a great application nowadays because of the electronic devices what we are using now. They emit a lot of electromagnetic forces, and this insulation foam, it protects. There are certain recent advances or research and development where now we can have high temperature foams also. That is foam suitable for high temperature requirements like up to 145 to 150 degrees C also, and they are now available in colors, like you can have white, you can have brown, you can have black. Now generally the foam or sponge, it can be classified into two categories, like open or closed cell foam. The further variables will be like it is the polymer could be rubber or it could be plastic, and both of them, they will depend on the density of the foam and the hardness of the foam. The insulation, it could be, the applications could be for insulation, for cushioning, for sealing, for damping, and for filtration. We'll see each one by one, and I've made some diagrams like this, so it will be very easy for you to understand what I mean. Now, this is an example of heat insulation. You can see some pictures, so that will help you to understand what I mean. Wherever heat is flowing inside a pipeline or heat is coming in from outside the atmosphere into the building, here is how you can use foam to control the heat. Here are some examples of cold insulation. Generally, it is applicable for various kinds of pipelines, and you can see the various kinds of constructions what we can have. This is for cushioning. See, we get our fridge, we get our washing machine or TV or laptop. You find this kind of insulation inside the box, or this kind of cushioning. These are sealing applications. You can see a person working on sheet foam. He is exactly cutting as per the requirements. Even the bends and the complex surfaces also could be very easily covered. Another important application is damping sound or vibration. We'll see how sound damping can be done. Some rooms are specifically made soundproof, that is made with help of foams like the pictures which are shown on the left hand side. On the right hand side, you will find some applications where the vibrations can be damped. Noise pollution is a big hassle to be tackled on shop floors, and foam helps a lot in this. Another application is foam is used for filtration. We see the filters in our automobiles, and you'll see a lot of the foam being here, the foam being porous. It allows air. The holes are microporous, so naturally it helps a lot as a good filter material. Some other specialty materials, as far as the vibration or this thing is concerned, these are the products which we use day by day. There's a toolbox, there's a helmet, there's a ear pad, there's a mask. The other special foam is the surface is very, very smooth. It is a very silky finish you can get. So by appearance and by acoustics, it looks very good. Moisture resistance, it can be provided with help of foam. It finds application mainly in building and construction. Another big problem is mold growth. In the olden constructions, we'll find a lot of mold growth, especially the areas where there's a lot of moisture, a lot of water. So with help of certain rigid kind of foams, we can totally get rid of this problem. This is a comparison between closed cell and open cell foam. We can have also a mixture of these two, which is called as a semi-open cell foam. What is the need of closed cell foam? So these are the reasons why it is required. Now there are various types of closed cell foams. It can be manufactured from neoprene, EPDM, neoprene and EPDM blend. It is also PVC or vinyl foam. You can have PVC nitrile blend or nitrile rubber. You can have foams from polyethylene as well as from EVA, ethylene vinyl acetate. The real name of neoprene is polychloroprene. Neoprene is a trade name manufactured by DuPont. These are the specialities or the properties of neoprene foam. It withstands good temperature. It has got good heat resistance. It has got good acid, alkali, fat, grease, oil, fuel resistance, and it has got even good fire retardant properties. Now, a grade is available where neoprene and EPDM is blended. You get the advantages of both the rubber in one. This is also UL approved for fire retardant properties. It has got very low resistance to oil, very good UV and ozone resistance, and reasonably a very good degree of fuel and oil resistance. These are the highlights of the properties of this blend. A major advantage or property could be, as compared to neoprene, the blend it costs a bit less than neoprene, without really compromising on the properties. Nowadays, this blend is also very popular. PVC nitrile. Nitrile is specifically elastomer or rubber, and PVC is a plastic. But by combination, you get a semi-rigid kind of foam, and it has got its own applications. This is how it looks. It is a tubular foam, and here you can get a density between 60 to 90. Generally, density for soft or flexible foams is to the range of say around 28, 30, but here you can go for even up to 90. It has got low compression set, very good ozone resistance. Now, there are certain requirements for the open cell foam also, and these are the few of the requirements. These are the typical applications of open foam: our seat, our household foam, the automobile trim, the filters, the acoustic, and the packaging. These are the areas where open cell foam is generally used. These are the few photographs, so you will be able to understand it very easily. In polyurethane foam also you will have two different varieties, like polyether, and the second one is polyester. You get say bit elastic PU foams. The combination or the manufacturing process or the formulation is slightly different, but then you can have some foams like this. These are the applications. This is a picture of closed cell foam. The manufacturing process is very simple. These are the top water I mentioned. These are the polymers or rubbers which are used, and there is a chemical foaming agent. They are mixed, and the batch could be of 500 kg or above size. And once the mixture is made, then the profile or the shape, whatever it is extruded into, is exposed to heat. Because of the heat, there is a chemical foaming takes place, there is a chemical reaction, foaming takes place, and CO2 is released, and that gas is responsible for the cell structure which is formed in the rubber sheet. Depending upon the dosage of the foaming agent, you can have smaller or bigger cells. These are the common applications for closed cell foam. I'll just go through the slides quickly. I got another 7 minutes, so I'll have to just go through fast. These are the common applications again for closed foam. These are few photographs, which you will find what it is. By mistake, I think this slide is repeated. These are some of the criteria for selection of a right quality foam. This is the material which is called as fiberglass. This was used earlier. Nowadays, it is almost discarded. This used to give a lot of irritation to skin, and the process to complete insulation used to take a very, very longer time. But with help of foam, the installation can be done very quickly, very fast.